Can you see my screen? Today's topic is hearing aids. In other words, auditory rehabilitation. So let us now I am not going to permit anybody inside. It's already 10:19. If you miss out, you can always get the resources from my classroom. And no issues. I don't bother about the attendance. If you want jolly well, you are welcome to give your name to your class representative and ensure that your attendance gets included in the register. I'm least bothered whether your attendance you have attended or not, because I believe sincerely that if you feel that you will benefit from my words, you will definitely attend. If you feel that you have better things to do than waste your time listening to me, you are welcome. No issues. So today I am going to speak on auditory rehabilitation, and that too auditory rehabilitation by using hearing aids. So let us go a little bit into the history. History is really interesting one. Hearing augmentation, what do you mean is amplification. Amplification, the concept of amplification dates back to the 17th century. And those days what happened was the king in a courtyard, in his court, usually he will have a member sitting in front of him. They will be seated wide apart. They could be whispering among themselves. They could even be passing snide comments against the king. But still, the king was able to hear every bit of the comments passed by his members of the court. How this happened? How this happened was, every chair in which the members of the court were sitting was provided with small holes, and these holes faithfully transmitted the sound uttered by the person who was seated in the seat, and it was transmitted by pipes which is hidden in the walls and floor, and these pipes faithfully transmitted the sound to the king's throne. And the throne had a trumpet like thing which was not visible outside. All the king has got to do is just place his head, sit back and ensure that his head was on the side of the trumpet. That will faithfully transmit the sound. Nobody knew that they whatever they talk among themselves could be heard by the king sitting so far away. So that was actually the history. Kings were notorious enough to record what comments were passed against them. So that was actually a small historical background to augmentation of sound. And Siemens, actually a German company, actually the first company to start manufacture of commercial hearing aids. So these are the two interesting anecdotes which I want to share with you. And then what exactly is the path which we traveled to reach the current stage of hearing augmentation? A path has been a very long drawn one. So let us go to the types of early hearing aid. You all know when you speak to a trumpet, your sound gets amplified. So trumpet was the first hearing aid to be conceived, perceived and used. And there are three types of trumpet used those days as a hearing augmentation methodology or sound amplification methodology to fulfill the requirement of a hearing impaired person. And then Townsend was the first person to conceive that a trumpet can be designed to transmit sound. So Townsend designed a trumpet, and it was aptly named by him. He was a deaf educator. Those days, special educators were trained to educate deaf children. So he designed this equipment to educate deaf children. So he called this equipment was called Townsend trumpet. This is actually a basic design of Townsend trumpet, which had two wide openings and a narrow middle portion. The dimensions roughly I have indicated just out of curiosity. This was actually used by Townsend. He will go stand by the side of the child. The child will be holding this trumpet one end to his ear, and Townsend will speak to the other opening. So he will be individually communicating with each kid using this trumpet. And then Reynolds was another person who designed another trumpet, and all these trumpets were just minor variations of Townsend's trumpet. And Daubney's trumpet is actually supposed to be a little bit portable because it was a collapsible trumpet. So you can pull something like a telescope, you can pull and push. So what happens when it is closed, so it becomes smaller. When the person wants to use it as an aid, all he has got to do is pull the trumpet, it will become bigger. So it was a little bit portable. They need not carry a big trumpet. This Daubney's trumpet was a little bit portable and a collapsible one. Rain actually, he brought in a different concept to trumpet. He actually is credited with the commercial production of trumpets. He manufactured customized trumpets on a large scale as per the requirement of the person. And the problem with the Rain's trumpet was he used a variety of materials to use it, starting from ivory to metals. So what happens, it was a little bit heavy to be held, and necessarily it had to be supported from below with one palm. So that was a very big drawback. And later he sat and modified these trumpets and came out with a slightly portable and lighter. He used lighter metal, lighter alloys to ensure that these trumpets weighed a little bit less than the conventional trumpets. Then this is out of curiosity I am showing you this image. This image was actually taken from one of the museums in London. See here, this was actually a flower vase. The flowers will be placed inside this flower vase. It will be on the table, and the pipe you see won't be visible. It will be hidden under the table. This will faithfully transmit the sound to the king's ear. So this was actually one of the tools which the emperors and kings used to overhear his conversation of the other members of his court, so that if they pass night comments, if they whatever things they talk about this king or whatever the thing they were talking amongst themselves will be heard by the king himself. So that is very, courtyard should be considered to be a very dangerous place, because kings always had a way of overhearing what others spoke. So this is actually a flower vase type of hearing aid. For your curiosity, I am just showing it. So this is as far as trumpet goes. Now we are in the electronic era, and before we go into the electronic era, we had an age of transistors. Transistors actually were the initial hearing aid base mechanics. Transistors were initially developed in 1948 by Bell Laboratories, and this was used inside the hearing aid. And William Shockley was a person who developed the first transistor. And transistor, invariably, it replaced the vacuum tubes. Previously, I don't know how many of you would have seen those radios which had valves. They call it valves. These valves are nothing but vacuum tubes which used to burn and transmit the electrical impulses. And it used to be very, very bulky, and they have a tendency to become hot. So transistors slowly replace these vacuum tubes, and they started making the equipment also less bulky, and the use of transistors reduced the size of the hearing aid. Initially the hearing aids were little bit bulky because they were using vacuum tubes as the electronic agent. So when transistors started to become commoner, it began to be incorporated into the hearing aid, thereby reducing its size and improving its efficiency. And the problem with these transistors was, these aids which are made using the transistors, they stopped working the moment the hearing aid got damp. So it is even sweat is enough to get the hearing aid damp. So that created a lot of problem. And later they started coating these transistors with a material that could that could stop the moistness from hampering the functioning of the transistor. And then use of internal circuit board or IC made the size of the hearing aid even more smaller. So now initially, this is again I'm going to what I spoke was current. Now I'm taking you back to the history. Initially what happened was the hearing aids were slowly introduced in 1870. This was actually a beneficial offshoot of telephone and microphone. Telephone is the first equipment which combined a microphone and a speaker. So the first electronic hearing aid was actually more or less designed like that of a telephone, and it was called as a acouphone. Since the design was more or less copied from that of a telephone, it was christened as acouphone. It was designed by Reese Hutchinson in 1898. And as I've been telling you about the vacuum tube hearing aid, this is actually a relic wherein these tubes, vacuum tubes which were used in radios, were used inside the hearing aid by naval engineer Hansen in 1920. And what happened was the telephone transmitter actually turned the speech into electrical signal. Then later these signals were converted to electrical waves which were amplified and then converted back to acoustic waves by the receiver. And mind you, the weight of the initial these type of hearing aids roughly around 7 pounds. Of course it was light enough to be carried, but still considered to be bulky. As an introduction, let me point out to you, we are all lucky that we have this important sense intact, because hearing disability is really common and it creates lot of problem. If you have a hearing difficulty from childhood, what happens is it prevents your language acquisition. And if you develop hearing loss, say down the line as you grow older, communication becomes difficult and you tend to spend lot of your energy in trying to comprehend what others are speaking to you. That is a real stressful thing, because we don't realize that if your hearing is not optimal, you will be spending tremendous amount of energy concentrating on the lips of the person who is talking and body language of the person who is talking, just to understand what the person is attempting to say. So a lot of energy gets spent on the cognitive load, causing stress and depression. Ultimately you tend to become depressed. So that is a real challenge any person with hearing problem or hearing deficiency faces. Now, what is going to be an ideal hearing aid? The ideal hearing aid should correct the loss of audibility. It should correct the loss of audibility, and it should in a way correct the hearing impairment. It should compress the amplitude of the sound waves. Even though it is supposed to increase the amplitude, it should compress the amplitude of sound wave. Why the amplitude compression should be done? The rate of amplification should not be drastic. So that if the amplitude compression is not there, what happens is if the person suddenly tends to increase the loudness of the voice, the hearing aid again will amplify the same voice, and on the sound level, decibel level, will suddenly shoot up to 80 to 100 decibel. So that will be a big problem. So amplitude compression is a must. And then with the advent of directional microphone, wherein the microphone has a tendency to pick up spoken words from any direction. So that again gives the sense of direction to the user. So that is again the most important aspect in an ideal hearing aid. And then noise reduction. The hearing aid should reduce the ambient noise level. Ambient noise is what the normal noise which surrounds you. This noise happens to be of the low frequency. It could be the running of a fan, it could be the humming of air conditioner. It can be these noises, the ambient noise, which should be suppressed so that the user can focus on the relevant spoken word. So these are the requirements of an ideal hearing aid. Now, no hearing aid or no technology is perfect. It cannot match the real one. So let us go into some of the drawbacks of our hearing aid. All the currently available hearing aid can be considered most as an amplifier, and it just amplifies the sound. So what happens is, when the amplifier works, it amplifies not only the spoken word, it also amplifies the noisy environment. So what happens is, the ambient noise, environmental noise also gets amplified. So the patient is unable to discriminate the spoken word when the environment is noisy. That is actually the problem with conventional hearing aids. So this is where the digital hearing aids come into play. So the currently available digital hearing aids have really changed the game, and it has managed to reduce the level of the ambient noise, and it has made the user to hear clearly the spoken word. So it clearly focuses and augments only the speech frequency. So what are the types of hearing aids? The broad classification of hearing aid happens to be, the hearing aid can be analog, purely made of transistor mounted on an integrated circuit board, or it can be a digital hearing aid. So let us go to the analog hearing aid. Actually, analog hearing aids purely, as I've been stressing again and again, it just amplifies the sound. It amplifies all the sounds in the same way. It cannot be programmed. You cannot program it, say that you amplify only the speech frequency, you don't touch the environmental noise. So these things are not possible. Of course, those days of analog hearing aids, it gave out a limited programmable ability. That was also came at a huge price. So now analog hearing aids are totally gone. It has been already replaced by digital hearing aids. Digital hearing aids convert sound waves into digital signals. So these digital signals, when it gets converted into a digital signal, it can be used by software, and these softwares can amplify specific range of sound, and it can even block certain sound frequencies. That is the beauty of these digital hearing aids. So these digital hearing aids invariably convert the sound waves into digital signals. So when the sound waves are converted into digital signals, your software program can manipulate these signals and make it convenient for the user to hear the spoken words. So your digital hearing aid contains a computer chip within that has a program which could analyze speech, word and other environmental sound, and then it has the scope. Even now, currently, some of the hearing aids have started incorporating artificial intelligence, so it can block all the ambient noise and preferentially augment only the spoken word. So since there is already a computer chip within the hearing aid, there is a huge scope for complex processing of sound during amplification. In fact, there is one mode called music mode. Supposing you want to enjoy the music in an auditorium setup, again you can go choose the music mode, where it will focus only on those frequencies commonly emitted by musical instruments rather than the spoken frequency or the ambient frequency. So here the digital hearing aid can be programmed to tailor the requirement of the user, and the same thing, preset program can be loaded into the hearing aid. So a flip of the switch is sufficient to change the mode of the hearing aid to suit the preference of the user. So now, what are all the base models of hearing aids available? The common hearing aid model, you would have seen people wearing a body-worn model where the hearing aid per se will be within the pocket. And then commonly used hearing aid currently is the behind the ear model, and then the more expensive in the ear model, or the receiver inside the external auditory canal model. These are the broad models of hearing aid which are commonly used. So let us go to the body-worn hearing aid. This is actually a photograph of the body-worn hearing aid. This aid has got the size of a cigarette box or a pack of cards. These were the first portable hearing aids to be introduced. This was designed by Harvey Fletcher. It has a casing. This case invariably it used to be made of aluminum or stainless steel. So this casing, it had a casing, the ear mold, this is actually the ear mold, and the wire attaches the ear mold to the casing. So this case actually would be placed inside the pocket of the patient, and the ear mold will be used to inside they used to put this mold inside the external auditory canal opening. So this is the normal body worn model. This hearing aid has advantages. We cannot say this is a failure model. This has its own unique advantages. What are those advantages? These aids provided huge amplification because the power supply is not a problem. Since it is a big, say it's as big as your pocket, it can hold a large size battery. So power is not a problem. And then next comes the feedback. You all know when you switch on the mic, there you can get a hiss, hum, all these things, feedback could be there. So while I'm taking a class, if many of you switch on your microphone, what happens is the ambience won't be so noiseless. What happens? You'll get tremendous feedback. So this feedback occurs when the distance between the mic and the speaker is very close. I repeat again, feedback occurs when the distance between the mic and the speaker is very, very less. But here what happens is the mic is within the pocket of the user and the speaker happens to be in the ear mold, which is inside the which is connected to the external auditory canal, and the two portions of the hearing aid are connected by a wire. So this distance really helps to reduce the feedback. So feedback is not a problem with body worn hearing aid, and more so these aids are cheaper, easy to maintain. I have already told you the ear mold contains the small speaker. So at this juncture, I can help to stress on one point. Say way back in 1950s, to increase the amplitude of sound by 80 decibel, one needed to generate 28,000 microampere or milliampere of current. I repeat again, to produce or generate 80 dB sound level, one had to use roughly around 28,000 milliampere of electricity. But currently available technology generates 80 decibel of sound with just 3 milliampere of current. So imagine how much of efficiency the current generation hearing aids will have. Now let us go to the behind the ear model. So behind the ear model, here these aids are usually worn behind the ear. In fact, there are two types of behind the ear model hearing aids. One is a classic behind the ear model. The other one is in the ear model. So let us go to the classic behind the ear model. So this is actually the image of the classic behind the ear model. Here these aids look different for both ears. This is actually a aid which you use in your left ear, and this is actually the aid which you use in your right ear. So these aids are semilunar in shape, and they actually the mirror image of each. If you keep close the right and the left ear hearing aid, behind the ear model hearing aid, they more or less resemble a mirror image of the other. So the same, the case is actually semilunar in shape. This is actually the casing which holds the electronics. This is semilunar in shape, and this hangs behind the pinna. This is placed behind the pinna along the post-oral sulcus or the post-oral glue. And this casing is actually attached to the ear mold or dome through a small tube. This tube can be made of plastic or can be made of Teflon, and this ear mold can be customized to fit comfortably into the entry of the external auditory canal of the patient. So ear mold can be customized. Patient using ear mold can be customized to enable the patient to wear this ear mold comfortably. So this type of connectivity, this hearing aid tube crosses from the superior ventral portion of the pinna up to the level of the concha. So at the level of the concha, the ear mold tip, actually this is actually the tip, inserts into the external auditory canal. So the case actually contains the electronics, the case contains the controls, the case contains a battery, and the case contains a microphone. Mind you, this case can contain multiple microphones. If this case is provided with multiple microphones, the user will have a better directional perception of the sound. The person will, if there are more than one microphone inside his hearing aid, what happens is these microphones placed in different levels or different areas of the hearing aid, they pick up the sound at varying intervals. This will give a sensation of distance and the direction of the sound to the patient. The speaker which is generating the sound can be housed within the case. And what they this unique design has got various advantages. It is highly portable, and they produce more output. The output is nothing but the amount of amplification. So it provides better amplification, and hence it can be used to manage patients with severe hearing loss, and it can be used to manage patients with all types of hearing loss. So this device has another unique advantages. It can be connected to other listening devices like FM or induction loop system. So currently all the classrooms in deaf and dumb schools, they are provided with FM devices wherein the teacher's class will be broadcast using frequency modulated signals, and these signals can be picked up by these behind the ear model hearing aid, and it can be amplified. So the students who attend the class in their special schools using behind the ear model hearing aid will be able to listen to their teacher as a normal child will do, because the teacher is broadcasting his entire words via frequency modulated signals, and these signals can be picked up and amplified by the behind the ear model hearing aid. Then another technology which can be used inside the classroom on a large scale scenario is the induction loop system, more or less similar to FM, wherein the one part of the induction loop will be on the table of the child, the teacher will be holding the other, and when they speak, this loop will be activated and the words will come out through the loop, and the hearing aid will capture those words, amplify it, and push it across to the auditory system of the child. And this type of behind the ear model is commonly used in children who need a durable hearing aid and who need a good amplification. Let us go to the inside the ear model. So here, as shown in the picture, this hearing aid can be pushed inside the ear, pushed to partially enter the external auditory canal. So these devices fit into the well of the concha of the pinna, and these devices, since it is slightly larger than that of the totally intracanalicular devices, totally within the canal devices, it can carry a large sized battery. So if the power supply is more, you can add better features to this hearing aid. So basic advantage of this in the ear model is it has a good battery backup, it has got a excellent power supply, and having excellent power supply will help the designer to pack in extra punch or extra features to enable the user to enjoy the sound. So what the main problem with this type of in the ear hearing aid is, when you start using this hearing aid, so it will be pushed inside the external auditory canal. So this portion which I am indicating by the cursor will be inside the ear, and this one will be seen outside. So what happens is, when it occludes the external auditory canal, there is a pressure differential between the this portion, the portion from the hearing aid to the eardrum, and the portion outside the hearing aid. So there is a pressure differential. So this actually hampers the pressure differentiation at the level of the pinna. So these patients can have excessive pain, blocking sensation in the ear, because air is not circulating freely from the atmosphere into the external auditory canal. For this to happen, you create a vent. You see a small tube attached here. This tube will ensure the atmospheric air circulates via this tube into the external auditory canal. So this ensures that pressure outside this hearing aid and inside the external auditory canal are more or less the same. This pressure equalization is provided by the use of vents, but mind you, these vents again can create feedback. Presence of these vents can create feedback. So feedback is one of the important complications or problems with this ear. So venting of the hearing aids will increase the feedback. And mind you, this is not recommended for children because the size of the concha and size of the external auditory canal keeps increasing as the child grows by. So you cannot keep changing the hearing aid every 6 months or 1 year because it's very expensive. And then this hearing aid can be connected to FM devices within the classroom to get advantage. The student who is using this inside the intracanalular hearing aid can attend the class and clearly hear what the teacher is saying via the assisted devices like FM devices. And now invisible inside the canal hearing aid. Here you see in this picture the entire hearing aid is within the external auditory canal. So these hearing aids fit the external auditory canal. It is not visible from outside. But mind you, this hearing aid should be customized to fit into the external auditory canal. So beforehand, you cannot manufacture one-sized hearing aid in large scale and start selling because one person's ear is not the same as the other. So you need to customize. You need to use a 3D CAD program to measure the dimensions of the external auditory canal and should design the hearing aid accordingly. And this hearing aid can be used in young individuals. In old individuals, the problem is they cannot have access to the controls by increasing the volume. That thing cannot be done. So they need to use a remote, and mobile phone can be used as a remote. A small software or app will be loaded to the mobile phone. The moment the user wants to reduce the volume or reduce the amplification, all this user has got to do is open the app and reduce the volume. And then if the user wants to go to any other setting, a music mode or a conversational mode, there are 6 or 7 modes like that, auditorium mode, classroom mode. So if they choose the mode, appropriate mode, using the app, the same thing will be changed inside the hearing aid by software. And this type of hearing aid is not advisable for old people because their fingers and hands lack the dexterity of young individual. Now let me introduce to another concept of extended wear hearing aids. Here these hearing aids are placed deep inside the external auditory canal. How deep? They can be placed as deep as just they can lie 4 millimeters away from the eardrum. So that is the amount of proximity they can go into the external auditory canal. They can be placed 4 millimeters away from the eardrum. So this type of hearing aid is very much suited for persons with moderate to severe hearing loss, and these aids, they don't distort the sound and they reduce the hissing noise or wind noise, and these hearing aids have absolutely no feedback. So that is the most useful aspect of this hearing aid. And this hearing aid also gives good directionality, good sound directionality. So suppose you use this hearing aid, this patient will be able to clearly say from which direction sound is coming from. And this hearing aid can be worn for longer duration because it is made of soft material and it has been designed to fit into the contour of the external auditory canal. The major problem is it needs to be inserted by a trained person, by an ENT surgeon or audiologist, using a special inserter or an introducer. And this can be worn continuously for a period of 3 to 6 months, and if the battery gets worn out, the hearing aid needs to be removed and battery replaced. Again, they need to constantly visit the surgeon or audiologist for even battery replacement. So that is a problem with extended wear hearing aids. So there is nothing perfect about hearing aids. Every type of hearing aid has its own benefits and drawbacks. So you need to customize the patient's requirement. You need to choose what sort of deafness patient is having and what are all the difficulties the patient are likely to face and also the financial situation of the patient before prescribing a hearing aid. Now let us go to the spectacle hearing aids. Here the hearing aid conveniently fits into the frame of the spectacles. So everybody above 40 will be using a pair of glasses. So hearing aid can be incorporated into the spectacles, and cosmetically it is acceptable to the patient. And two types of spectacle hearing aids are possible. One is the bone conduction, wherein the conduction of the sound into the ear occurs via the bone, and the other is air conduction spectacles, wherein there will be a small cable coming out of the amplifier inside the spectacle, and it will be connected to the speaker, which will be placed into the external auditory canal. So bone conduction as well as air conduction type of spectacle aids are possible. But let me caution you, the bone conduction spectacles, they are not receptive to high frequency sound. So the user may have difficulty in listening and perceiving high pitch sound. So that is a big problem as far as bone conduction spectacle hearing aids are concerned. Now this is the currently available technology. Every one of you have a mobile phone. You all know that your mobile phone has got a mic. So this mobile phone can be converted into a hearing aid by installing an app. So what the user should do is he should wear the hearing aid in such a way that it is exposed, the mic of the mobile phone should be exposed to the ambient sound, and then a speaker cable, you all use a headphone. The headphone can be attached, and it can be attached to both the ears of the patient, and this will work more or less like a conventional hearing aid. But mind you, the distance between, as I've been stressing, the distance between the mic and the speaker is so much that there is absolutely no feedback. And every one of us now currently, irrespective of the age, they know how to use mobile phones. And I need not tell you, a battery of your mobile in fact could last the entire day, and it can, all the complex audit sound processing can be done by your mobile processor, because the currently available mobile processors are huge and the amount of memory available are huge, and this is the fast catching up hearing aid application. And let me confess, I am convinced that all your hearing aids will be, all the hearing aids I have shown you right now will soon be confined to the dustbin, provided people take up to this hearing aid application, app based hearing aid using your mobile phone. This is as far as the types of hearing aid. Let me go to the components of the hearing aid. The major components of the hearing aid includes microphone, next comes a processor and amplifier, and the third comes a receiver. So I am not going to talk much about the microphone because of the paucity of time. So I'll be pushing out a literature on it. You can go through it. Then let us come to cross. Cross is actually another concept of hearing aid, which means contralateral routing of signals, wherein the microphone is placed over the poor ear, and then as shown in this picture, the microphone is placed in the poor ear, and the signal from the microphone is transmitted to the better ear, which has the receiver and amplifier. So sound from this ear will be amplified and pushed to the better hearing or good ear. So here this type of hearing aid, cross type of hearing aid, is useful in treating patients with unilateral severe deafness. This is very useful in treating patients with unilateral severe deafness. And mind you, since you are using a good ear or better ear to hear the sound from the bad ear, amplification need not be so much. So amplification of sound need not be so high because you are using a better ear or a good ear to hear the sound from the bad ear. And as I have been telling you again and again, say as soon as I showed this slide, mic is placed inside the, close to the bad ear to pick up the sound directed towards the bad ear. And since better ear is used, amplification can be, need not be set to the maximum. There is absolutely no feedback, and the directionality of the sound is not lost. There are some modifications which has taken place as far as this cross type of hearing aids are concerned, it's known as something called bicross. This type of hearing aid is actually used to treat bilateral asymmetrical hearing loss. Supposing the patient is having bilateral hearing loss with hearing loss worse in one ear, somewhat better in the other ear, you can use this bicross type of hearing aid. And then something called stereo cross. This is actually a recent advancement wherein you can use this. If you use this type of hearing aid, your binaural functionality of the ear will be restored. So the binaural function has got a huge role to play when you enjoy music, when you go to public places where this gives you an accurate assessment of the direction of sound and the distance from which the sound is coming. So these things can be assessed by providing a binaural hearing function. So that is actually one of the beneficial modification of cross. Now let us come to BAHA. BAHA is nothing but bone anchored hearing aid. These are all again implantable hearing aid. In this type of implantable hearing aid, one portion of the hearing aid, which happens to be the titanium screw, should be first surgically implanted into the bone. That is actually, we prefer the mastoid bone because that is the closest to the ear. You drill out a small hole where your titanium screw will be pushed in, and you close the opening using bone putty or bone paste. Allow the titanium screw to get integrated with the bone. That is called osseointegration. So this, after the osseointegration has occurred, usually it takes 2 to 3 weeks for osseointegration to occur. As soon as that has occurred, this external device, which is actually a hearing aid, gets screwed into the titanium screw here. So here this hearing aid directly stimulates the inner ear via the bone conduction. So which patients are known to receive this type of hearing aid known as BAHA? If the patient is having bilateral external canal atresia. If the patient is having bilateral external canal atresia, there is no way you can put a hearing aid because there is virtually no auditory canal. So you can't push the hearing aid speaker into the ear because there is no opening. So these patients ideally deserve a bone anchored hearing aid, and these patients should have adequate bone conduction threshold. That is one of the major major things the patient should have before going in for BAHA. They should have a good bone conduction threshold, so they should be able to hear well the sound conducted via the bone. So you need to have a good adequate bone conduction threshold because BAHA conducts sound via the bone. So that is this is as far as BAHA is concerned. So that completes today's class. If you have any doubts, you are welcome.